One of the solutions that's been proposed within recent memory is this idea of mountains of data, right? More and more data provides more and more understanding of the distributional characteristics, the entropy of that space, and the more data you have, the less problems you're going to have with overfitting, right? More samples makes it harder and harder for the system to memorize any individual sample, especially whenever you bring in things like batch normalization and augmentation, because it's going to make it almost impossible for it to keep track of the attributes of one sample out of 100 million, right? Or out of 1.4 trillion images that are part of like ImageNet Prime, right? There's a, I think the 7 trillion image data set that Google used to train part of some of its backend now, all right? So that's like crazy, crazy amounts of imagery. And that's not even considering the fact that we can take videos and drop them out as frames to train image processing systems as well. All right, now those frames are not going to have quite as much difference from one another. There's going to be a lot more consistency across frames, but things like random pruning can come into play. Big data is part of the solution framework for solving some of the problems that we want ML to help us fix. Okay, whenever we are looking at true knowledge-based application, what did I just describe? I said, you have a model, you know how that model works, you read the paper about where the model came from, okay? I know a lot of people who work in graduate study programs where you read a paper, you look at how they went about it, right? You take their model, you grab it off GitHub, you get the code and all that stuff, and then you're going to make modifications to that model and try to make it better, right? Iterative improvement is the name of the game in academic research. In business research, you don't even have to iteratively improve on the model. You just have to figure out how to take the one that somebody else did that's open source and apply it to the task, right? Which makes it a little bit better. Take it and apply it to something and say, hey, I saved your company, 14 picoseconds on every project you have, right? Say, give me cash, right? So, maybe you make it vastly improved over their system, right? You save half the time, all right? So you could we call it digital transformation, right? Say, I brought in an algorithm and all of a sudden you went from some level of efficiency up to like a square of that efficiency, and you go, wow, you changed the paradigm of that entire workspace. There are many areas that are looking to have those breakouts of taking existing trained models and applying them to these tasks, either transfer learning them or direct implementation of the model spaces. So all you'll need to really know 3 or 4 things, how to do 3 or 4 things well. Okay, so you'll specialize after this. If you continue working in ML, you'll find your thing, you'll find your niche, all right? You might have a bit of generalist knowledge from a baseline, but you'll have specialization. That might be in understanding how the mathematics of the back-end function in order to try to make things run more efficiently. That might be building pruning networks. It might be selecting topologies for image processing, selecting topologies for audio signal processing, right? So are you guys in NLP class as well? Yeah, so audio processing is a big factor, right? There's other types of signals besides vision signals that we can decompose into things that will feed in to structures and tensors and transform model frameworks. So if you know how a couple things work well, you should be able to make it work a little bit better. Basic 3-step process that you really have to require in order to be able to understand what we're doing in this space. Define a metric, okay? This is in alignment with something that is called one of the central axioms of engineering, and that is what is measured is what is improved. We've talked about loss functions, right? How you describe your loss function, what the relative fitness of your model is with respect to what you want to try to have that model be better at, is going to be the key, one of the key things, probably the most dominant thing you're going to have to select early on in the ML space. You want to build something that is relatively end-to-end, all right? So at this level, I think you could say ML is effectively full stack in a sense, right? Because you're going to have to go from raw data to actionable intelligence on the other end of the system, right? You need knowledge bases constructed from raw inputs. So we have to be able to have an understanding of both the data transformation space, the pre-processing stages, at least those that are necessary in order to get it into the configuration we want. And then we have to understand the topology characteristics to transform it within the network into something that's going to be meaningful for the outputs. Feature extraction methodologies, regularization, normalization, batch processing, those things that are going to be able to get it to where it's deployable on the space. The reason why I say specifically focus on this being end-to-end is that end user is also considered in this space as well. Because if your model is deployable on some kind of platform, you have to think about how it works in that platform space as well. One of the things here is that we're going to be driven by refinement with respect to the performance that we're taking as our principal indicator, right? We're going to get better at doing whatever we objectively set as our goal. So one of the things that I like to say within this space is, if you want to improve profitability, what are you going to do? You're going to have to reduce costs somewhere in the system. So this is a risk that comes along with that idea of optimization in all spaces. Sometimes it takes risking money, it takes having a potential loss in order to maximize output. Machine learning algorithms aren't really great at that, right? But people are good at analyzing the data that's coming from it. So many times you're going to have human-in-the-loop driven refinement processes in order to optimize the machine learning model frameworks. So you need to make the output from those systems interpretable as well. That might be the additional factor that I would put in there, is that the driving force of this data refinement framework might involve how you express what that model is understanding from the visual space and translate it into something that someone can understand, make it sort of parsimonious. When we think about our loss in terms of processes, we may have high or low accuracy constructs, high accuracy application, surgical robot, right? You want it to go exactly where you said you want it to go. What about an app that tells you which celebrity you look the most alike, right? You don't need to have a high accuracy model for that, right? That's just a dimensionality projection space, right? Here's a space in which the celebrities are adjacent. Take your visual model, reproject the visual model in that adjacent space, and find the nearest neighbor. That's easy. That's a fairly simple task, but it's also a situation where you got to think about what are the metrics to take into consideration. How many dimensions does that space need? What's the utility of it for the user, right? How fun is it for them, right? What might they be able to do to make themselves look like a different celebrity or something like that, okay? So the reason why I say that the utility of something is related to its usability, and its usability is related to its adoption. Nobody's going to use something that is either not robust enough for their considerations or has glaring defects in its uptime. This is a situation where reliability is going to come into play. We don't talk a lot about reliability in engineering in general, but reliability is said to be the difference between what we would like our software to do and what it actually does, okay? It's similar to the idea of MSE, right? It's the difference between what we wanted as an output and what we got as an output, but it's much higher level, it's much more abstracted. So you have to think about what you want in terms of accuracy in operation versus stability in operation, and those might be trade-offs in certain circumstances, because nothing is ever going to work perfectly. So how we build our metrics is going to be an important part of the process. We talked about these previously, but I'm going to cover them again because you're going to be getting metrics from your models as you train them. Many of you have already seen these and probably are already parsing them fairly quickly. But accuracy, right? Accuracy, it can be a little bit deceptive. Why? Because there could be a lot of different places in which you can have error in that system. But we might have something like sensitivity versus specificity as a better overarching metric of being able to describe the performance of the model in certain cases. If we want a highly sensitive model or we want a highly specific model, we're going to preference towards those distributions within something like a confusion matrix, okay? The confusion matrix is just a visual representation of the ratios of things like true positive, true negative, false positive, false negative, and the extraction and abstraction of those score metrics to try to flatten out the overarching performance of the model. We want to have it interpretable by somebody that doesn't have a lot of knowledge of what's going on with those arcane mathematical processes inside of it, right? There's a relationship to this necessity of something you guys are modeling right now that you're not aware of. That what I'm trying to have you do with respect to the reports And the communications that you're making to me about what you understand of these models is effectively the same thing you will be doing whenever you get out into the workforce. Whenever you go into that meeting with somebody and you say, okay, let me explain to you what I did, right? Here's how the model performs and operates. Here's how I was able to iterate on the improvement in performance. That's exactly the job you have at the end of the day, is to make that arcane, crazy mathematics behind this whole system that we as engineers have the desire to learn and understand, that the money people on the other side of the system really don't. They just want to know, does it work better than the one we had beforehand, right? Did all the, $100,000 I paid you last year actually create anything of value, okay? So you gotta have a little showmanship. I'm gonna be serious about this. You gotta put on a little bit, okay? There's actually a term that, and I heard this term for the first time when I took this class many years ago, and it's called jobfuscation, okay? Obfuscate means to like hide something, right? Job is what you do. So jobfuscate is to hide what you do, okay? So the reason behind that is, if you say, look, it's just a bunch of mathematical formulas, you plug this in and it does the thing, your boss says, what do you do here again? Right? You push buttons, like, okay, now I get it, right? No, you say, it's a crazy, arcane, complex process that's running all these matrices in the background. You throw up some of those nice diagrams on your screen, right? For 4D tensors doing things during training operations, and they go, wizardry, right?
Yeah,
so that's what you want. You gotta have a little job, you gotta have a little showmanship, gotta put a little pizzazz on it, okay? Don't oversell it. Don't become a hype meister, that's not the point. That kills machine learning development. If you love it, don't kill it, because that's what will happen when you overpromise and underdeliver. What are we in right now? We're actually in a hype cycle. What happens at the end of hype cycles? AI winter, okay? AI winter has come every single time a hype cycle has failed to deliver. So if AGI isn't around the corner, then everybody's promising it, right? And everybody is hoping that it will just all be able to sit back like, in the orbiting planet, drinking our soft drinks on our floating couches, just like Wall-E. I don't know why everybody's aspiration is just to do nothing, but that there is this aspect, right, where laziness is inherent in our makeup. But the point being, if we don't deliver on that, it's going to be a disappointment. People are going to divest. People are going to wait for it. And there's going to be a dearth of development in this space. Usually what happens, though, is we have to find some new way to go about it. That's the reason why I say the area of metric development, finding the right thing to chastise the model for, the right mistake to be able to say, no, this is the way in which you look at it, requires being able to go in, find out where those errors are occurring, and then be able to put the appropriate penalties on those loss and optimizer functions in order to get it to do something else, right? It's always going to maximize score. It's always going to minimize error. You've just got to figure out how to penalize it in the right way. So coverage, precision, TPFP scores, recalls, total amount of error, system error, right? All those metrics can be utilized to refine our understanding of how the network is performing with respect to images being classified or signals being classified, whatever else it is. There is an example here, and I was looking at this earlier because the next program, okay, so for clarification's sake, our exam isn't Monday, our exam's Tuesday. I am going to do a review for you guys as a video, okay, so I'm putting that together. I'm going to do it in conjunction with that, the other thing. I'm going to put two things together, okay? One thing is going to be the natural process flow for doing the backprop. So it's going to go all the way from basically beginning of class all the way up to where we have for material in that space. I'm going to try to see if I can get it done by tomorrow afternoon. Fingers crossed, that's really where I'm aiming, okay? So I will try my level best. Monday, I'm planning on trying to give you guys an additional assignment, okay? I said they're going to come fast. I may even give it to you earlier than that just to have you be able to look at it and think about it in advance. Don't panic, focus on your exam, of course, but let's kind of look through that framework. What we're going to be doing is working with color image data, okay? We're just going to move on from what we're doing with black and white. We're going to do it with color. We're going to see how different that is, come up with a few different topologies and try those topologies, and mess with some of the individual parameters there. It's not going to be quite as complicated in terms of adjusting all the parameters, and it's going to be entirely CNN based, okay? But the reason why I mentioned this is I was looking at a data set and I was planning on using it, and then I realized something about it that was really bad. It's called Safar 100. It's a 100 class data set that has a exponentially decreasing number of samples in each class. So class 0 has 500 samples, and then class 99 has 5 samples, okay? So it's weirdly disbalanced, and as a result of that weird imbalance, there's a lot of additional things you have to do in order to try to analyze the optimization performance functions, okay? So I steered clear of that one, but that's an example of a situation where you're gonna need some pretty comprehensive metrics, because what's gonna happen? The model is instantaneously probably going to consider everything to be in class 1, right? Or excuse me, class 0, right? It's gonna make it all in the dominant class. Because guess what? That's fairly safe, right? That's a fairly safe space to be. You're gonna have to get it to come off that and say, no, I'm penalizing you for making the wrong mistake, right? I'm penalizing you for making everything class 0, because say, hey, class 0, I got it to be like roughly, 17% total accuracy, right? I got there, I got to the maximum I can do by putting everything in one class. But that may be an optimization from its perspective, from the model's perspective. We have to implement additional processes to be able to say, no, I'm going to throw in scaling factors. I'm going to throw in penalties for out of class greater than in class, right? So those things say, like, effectively a greater penalty than reward for correct classification might be an option for building an optimizer at that level. All right. One of the tools we're going to have to look at, and this is a situation why I'm kind of on this kick of describing and developing these models pretty quickly, and that is because that's actually fairly common within the industry, okay? I know this is the first time we're really building these, so I am putting you underneath a little bit of strain in that respect, but what are you really programming, okay? How many of you have really programmed in the class so far? No, it's not really a programming class. There's things you can do programmatically, right? You can implement those as metaparametrics and the modeling framework supports around them, like we talked about with the iterative trainer, right? That's a thing you could program. The output system, you can program that. But those are tangential to the actual core working the process, okay? We programmed, right? Took an existing Python and made some modifications to it. Some of you tried your own backprop systems beforehand. Pretty complex, okay? But what I say is we've already got so much. We're standing on the shoulders of giants. We're effectively asked to go out in the world, and somebody's going to go, here's some data. What can you do with it? Okay? You're going to hop on Google. You're going to start looking up data sets comparable to the one you have. You're going to look up models trained on those data sets. You're going to pull down all the models on those data sets, and then you're going to start throwing those models at the data set and saying, okay, which ones are performing well in this data set? Then you're going to make modifications to them, maybe hybridize them, maybe breed them together like little Pokemon, right? And you're going to get your new network that you're going to construct from that, okay? Those ideas are about this process of rapid deployment and rapid refinement. That is a functional requirement for being able to be successful as an ML engineer, okay? So, do you have a question?
I was going to ask,
yeah, please.
If you don't mind about the exam, you said the exam is going to be on Tuesday. Is that the multiple choice portion and the?
It's going to be both. I'm not really going to have a separation. I thought it was going to happen. Did not work out as well as my previous experiment. So those guinea pigs saved you. It is going to be 37 pages. No, just kidding. No. It's going to be our standard length of time long. All right. So I'm going to try to target it right around that range. It will have a mixture between multiple choice components and fill in blank, as well as short answer and diagramming, okay? Mathematically, I'm going to try to keep it very light, but you still might want to have a calculator in case you need to check some work, all right? But I would probably be the most complex thing on there, maybe be some, figuring out the dimensionality of an output vector or calculating the forward passive, a network or something like that, okay? Those things that we already relatively have a good idea how to work. Maybe some transposition, right? I give you a matrix and then you have to draw the network and then you have to do the forward prop. That's a situation where I'm trying to be meta-analytical with you, right? Get up above it, look down on it, understand what the global perspective is for this space. I will try to, along with the review, provide some example questions, but there's only so many questions that you can ask, okay? So realistically, it's just recombinations on those questions. If you want to know the kind of questions that can be asked, we have the Great Oracle. Before we had the Great Oracle, we just had the regular internet, okay? And there's tons of other classes that have this same name, deep learning, in other different programs around the country. I source from those, not gonna lie, okay? I go and grab tests from previous semesters of other classes in different spaces, because it gives me a different perspective on how to write it or how to look at it, all right? I'll reword it, I'll respace it, whatever else it might be. But a lot of that stuff is, the focus of that is just to try to find what the general interest is. Obviously, that to me is kind of crowdsourcing this notion of the knowledge that's necessary in the space is very comparable to the idea of trying to prep you for what's also out there in terms of the job market, right? What questions are you gonna get asked on a job interview? Effectively, that's gonna be the same kind of thing I'm gonna ask you. Yeah.
And so we have like an ISL class, we had a note sheet. Are we gonna be able to have a note sheet for that as well? Or?
No, unfortunately not. Note sheets are done. My ISL class for this semester killed note sheets for me, period. There were too many people that brought in note sheets that had full written answers to questions, and I had somewhere in the neighborhood of like 4 or 5 students who had virtually identical tests, almost down to the word, because they were copying off of their note sheets. Okay, so I will provide you with a formula reference.
Okay.
I will give you, and I have it about 90% done as it is now, and I will give it to you in advance. Okay, here's what my thought process is. Maybe if you guys come up with something and you go, hey, could we put this on there and kind of crowdsource from you guys a little bit? I'll see if I can do that. Okay, I popped it up in. Right now it's in PowerPoint so that I can add clipped images from some of the slides. So mostly just formulas. Sometimes it'll be definitions, right? A little bit of workflow there. Maybe like one example framework.
So we can't bring our own.
Nope, unfortunately no. I'm not. I've decided that that's really not in the scope of what we're doing here. So I set the level of the exam relative to the resources that are at your disposal, right? So if you want to make the class harder, then need a worksheet, right? That's where I look at it and say, without the worksheet, I can't expect you to know every definition, right, under the sun, right, verbatim. I'm going to be asking you more conceptual questions at that level. So high-level stuff, focus more on the generalized understanding, but I'll try to provide with frameworks for one sheet of formula reference.
Just one last question. The one thing I'm kind of still uncertain about is making sure I got the backprop math 100%. Is that going to be that part of the video you're going to post, is working through the backprop?
Let me tell you this. I'm just going to go ahead and stop this anyway because we're done for the moment. I do not have a question requiring you to calculate backpropagation math at the moment. It takes a little too long, okay? And that's just realistic from where you guys are at. Part of the reason why I made it an assignment is because of the fact that I wanted you to at least have the opportunity to do it once. What might be there maybe is something like an eigenvalue, because we talked about eigen decomposition, but I'm going to show you eigens again, all right? That's on the review. It's on the beginning segment of me describing the backprop, okay? It's stupid easy, okay? Very, very easy. It's just one formula, and I'll add the reference to that on how to do it. What I say is, I know it's difficult whenever, especially, this is a situation, first time that I'm teaching it in a couple of years, right? You guys don't have my test to go back on from previous semesters from all your people that give you tests from last year, right? That's what's scaring you to death right now. I know that, okay? I get it, right? So I'm gonna try to keep things in a situation where if you've done the work and you've moved forward, you understand what we've been doing, you should be able to get it, okay? Questions on code, questions on implementation of things we've done in exercises that you've done on your project stuff, that's open game, that's fair game, okay? I can ask you about whether this is an appropriate implementation. I can ask you about parsing that line of code and be able to tell me what's going on, all right? But that should be straightforward because all of you have had that stuff upside down and inside out already, okay? So that should be fairly easy. Backprop is going to be conceptual, talking about terminology and process of flow. And if there are formulae that are referenced, I will give you the formula on the on the sheet, okay? So you don't have to derive your own, you don't have to do the derivations of the activation functions. That was something that they did like last year, and I was like, that seems like relatively something that like you just write down. You don't have to do it again, Universal approximator, I'm going to recover that, okay? We already did it once, but I've had this goal in mind of doing it as part of a review, all right? But it's just going to talk about that relationship between linearities, how linearities become non-linearities, how they recombine to create features, etc. Watch the videos, 3 Blue and 1 Brown videos for that high-level understanding and some of the, method understanding. And I will work through the example of the backprop we already had on there, showing you stepwise through on the example. That's what's on part of the example right now. I should have, like I said, my goal is tomorrow afternoon, early evening, have that for you. End of day tomorrow, we'll get that started so that you can have it and start working on it, okay? Don't forget, you do need to spend time finishing this up. It's gonna be due Friday night for this project too, okay? I can't extend it any further forward from that because I don't want it to distract anybody from prepping for midterm on Tuesday, okay? Thank you very much. I'll talk to you guys soon. If you have questions about it as it goes forward, we'll talk more on Thursday about exam parameters. I'll try to maintain whatever level of specificity makes the most sense. So